Yes.
Hello friends, this is Durga from IT Varsity. Those who join from YouTube, as you guys know, this is just a backup for my live audience who are joining the session through WebEx. So if you have any questions, we might not be able to answer all your questions, so bear with us. That being said, I hope, already those who are on WebEx confirmed that they can see my screen. So today's agenda will be primarily on, sorry, on data frames. So today, tomorrow, we will mostly cover the data frames. Day after tomorrow will be the last class, and I will be covering different file formats, and also I will try to cover how to think through the problem and decide which Spark APIs you should use. Okay, so that being said, you can see the material for data frames here. So if you want to be master in data frames, you have to be good at SQL. Data frames and SQL are tightly coupled. And also one of the way to create data frames is Spark SQL. Yeah. It's not coming on YouTube. Just bear with me for a moment, okay? It is coming, so we'll start. Okay. So one thing is data frames is primarily used when the data is structured. Rather than, sure, Kishore. So this is the URL. Let me do it in the YouTube also. Okay, so this is the link for the lesson. Okay. So the rationale behind, just give me a moment, okay, I will mute. I don't know how come it got unmuted. So today also we are doing the session in WebEx. So if you have any glitches, let me know immediately. It seems they have released a patch around 10 days back. And that was the reason why last week we had many issues. I hope this week, actually last couple of weeks we have issues. I hope this week we might not see that issue, but let's see. Okay, so the rationale behind data frames is in many cases data will be structured. Rather than writing code, we can leverage simple interfaces such as SQL to process that structured data. And also we can actually take care of additional optimizations. For example, without SQL, if you try to just join two data sets on a primary key which is of numeric type, you have to convert its data type once the data is loaded into the file system. Okay, so for that reason, we the data frames or Spark SQL take care of those additional optimizations. And there is same execution engine for different programming languages. We have Spark SQL, we have Spark SQL with Hive, we have data frames. For all these things, there is a common execution engine. Even if you try to use Python with Spark SQL and all, it uses the common execution engine, irrespective of different frameworks or programming languages which you try to use to process the data. And the typical transformations which we have seen already are filtering the data, cleansing and standardization of the data, aggregations, sorting and ranking, joining the datasets, and also analytic or windowing functions. These are the things which we perform as part of SQL. Analytic and windowing functions you might not be aware, a lot of people might not be aware. I'll be covering briefly about them as part of tomorrow's session. And it is very important, analytic or windowing functions. It actually eases lot of eases the implementation for a lot of complex problems. Okay. So for this purpose also we will be using DataFrames, the retail DB database. The one of the foundation part of DataFrames is either you have to use Spark SQL, or you have to use a traditional way of loading the file into the RDD and create a structure out of it. So to create the structure for the latter part, you have to use case classes. So that's why I have emphasized a lot on case classes when we spoke about earlier. So we will revise case classes a bit now. So she is asking what execution done Spark. So the question is what execution Spark SQL use in background. It uses Spark, irrespective of the context you are running. Okay, so this is the simple starting point for the data frames. If you want to load the files and then apply the transformations on top of it. The transformations can be done using Spark SQL or DataFrame operations. Okay, so case class is very important. So I will review the case classes now, so that you recollect what case classes are. It is very important to understand the case classes. So I'm launching Scala here, and if I create a case class, no, this is not correct. So if you actually go to the lab, I don't know, you might not have seen the Ambari. I will highly recommend you to go through Ambari and review this, review what is there on the cluster. Okay, it is not correct that Hortonworks restore does not come with Spark engine. And I have been using the same cluster for last 3-4 weeks since I started Spark, and we use the Spark engine which is available here. And also I have been connecting to the lab and launching Spark Shell. So I don't know why you feel that the Spark engine is not provided as part of Hortonworks. This is Hortonworks distribution, and you can see Ambari is the cluster management tool. So your statement is completely incorrect. Okay, so now you have a case class, and you can see the structure by using the javap command. Okay, so you can see the main thing is this case class is serializable. It implements an interface called serializable, which means that we can actually write back and forth from memory and the HDFS. Sorry, memory and the underlying any file system. Okay, and the follow-up question from Sri. No, you cannot do this. You cannot run Spark queries So your question is about Spark SQL, not Hive. Okay, Spark SQL you might not run in Hive. Some recent versions are supporting Hive. From Hive itself, you can invoke the SQL using Spark engine, the same way you can do with the Tez or MR. But in the earlier versions, I think even in this, you cannot actually set this one. So here the confusion is you have mentioned Spark SQL. If the question is what execution engine does Hive use in the background, then it can use MR or Tez, whatever is available using this option. Spark is not available yet in this. But as I have explained as part of the last class, either you can use Spark SQL, where you can actually run Hive queries in the Spark context, or I have also demonstrated where you can launch Spark Shell and use the Hive context object to execute the SQL queries. So you will actually run the queries as part of the Spark related command line interfaces to use Spark engine as of today. But probably in future versions, even if you have Spark on the cluster, you should be able to set the Hive execution engine to Spark, and you can validate your queries from Hive itself. That is possible in future versions, but as of today, it is not possible, whatever version I have on the cluster. Okay. So this is the most important. It is serializable. And also, if you recollect, the case class will have member variables with getters so that we can actually get the data. And also setters to actually set the data. So this is the getter, and there is no setter here. There are only getters because by default the variables are of immutable type. If we change it to var, you will get setters also. Okay. That being said, on top of this one, case class also creates a companion object, and that is very important to see that. And if you see here, there is a special method called apply. It seems to be struck. So tomorrow I will actually send invitation from Amazon Chime. We will try using that because still WebEx haven't fixed the problem. So we will try Amazon Chime tomorrow. Okay. For today, let's. So when I posted on LinkedIn, some of the guys told that they might be releasing the patch over the weekend and it will resolve the issue, but it seems they haven't. So we will see later. So one question here is from Piyush: can you cover shared variables? No, we are way too much delayed. I will not be able to cover accumulators and broadcast variables as part of the course. It was there in the original plan, but due to the delays, already I have extended from 20 hours to 22 hours. So what you have to do is you have to go through this more Spark concepts and core APIs. You can actually go through accumulators and broadcast variables here. And also, if you actually go to my earlier classes, okay, probably you can actually see the CCS Spark and Hadoop developer. These two are the ones which you need to look at. And it cannot be covered in 15 minutes. It will take at least 1.5 hours to 2 hours. So I will highly recommend you to go through these two topics. And if you have any questions, you can write those on discuss.itworks.com and we will be glad to assist you if you are stuck somewhere. Okay, so I will recommend to go through this. So that being said, this apply method is special and we'll be using that a lot while converting our data into the data frames. Okay. So before actually getting into that, let's see how we can actually create a orders type object for this case class. So I can just say val o equal to orders, and it takes 4 fields. One is order ID, second one is some string. It is typically date. So I'm giving August 1st as the date. We can put any string over there, and then we have integer, which is order customer ID. And then we have status. Okay, because of the apply method, we can create the object without using a new keyword, and it will actually return something like this because the two-string operation is overridden, and this is the behavior of the two-string operation. Okay, so now what we can do with this is, so when we actually load the data from the file system, typically it will come like this. It will come as string, okay, something like this. Okay, and then, okay, now S is of type string. So as part of the math function, we have to convert this string string into the orders object. So what we can do, we can say val c equal to s dot split comma, because our comma is delimiter. So C have 4 fields now, or 4 elements in the array, and using this we can actually create the object. So we can also say val O equal to C of 0, but this is of type integer. Even though the element is represented as string in the array, it is originally of type integer. So it is our responsibility to change its data type while creating this orders object. So we will do like this: orders of C of 0 dot to int, and then C of 1 dot, no need to convert into string because it's already string, and then C of 2 dot to int, and C of 3, and that's it. So now you have created the object for the string. So for each input record, we have to apply the map function, and as part of the map function, we have to implement this logic of splitting the string into array and then creating the object out of it. Okay, and then once you create, so what it will result? It will result in a RDD. So you load the data from file system into RDD, and while loading into RDD, we are also converting into orders objects. So the final output after the map function will be RDD of orders, and then we can actually change it to the data frames. Once it is changed to data frames, we can use many features of data frames. We can register as a temp table and run Spark SQL queries against it, or we can keep it as data frame itself, and we can actually apply something called data frame operations. Data frame operations is another API to process the structured data in an effective manner. If you are familiar with Hibernate, you have something called Hibernate QL, right? Similar to that, even data frame provide you some operations which you can perform on the data which is converted as data frames. Okay, so now let me. I'm in this. I'm in Scala, so I'm exiting from here, and now I'm starting Spark Shell. Okay, first I will be covering data frame operations. I will not be covering Spark SQL. I will talk about Spark SQL later. So if you want to use Spark SQL, then you have to register as a temporary table, and you can run queries against the data frames. Yeah, I'm running on my local PC itself, so I'm running in local mode. That's fine. Data frames will work without any issues. But if you want to run Hive queries, then the local mode will have issues because we haven't integrated with Hive Metastore and all those things. So for today's session and also for majority of tomorrow's session, where I'll be covering Spark SQL in native context, not in the Hive context, the local Spark shell is also works. Only when we try to integrate Hive, as we haven't set up Hive on our PC, you will face some challenges. Hence, it's better to use the cluster. Okay. So now let us first create orders data. Okay. So sc.text file, because it's the data is of text input format, I'm using text file itself, and then users /itversity research data retail underscore db and orders. Okay, so this will actually create a RDD of a string, and each string is nothing but one line from this data set. We have covered many times in the past, so I'm not getting into details here. Then we can use map function. Map takes each record at a time, and it accepts it accepts a function as the argument. And as part of that, we have to provide the functionality, and the functionality is take one parameter, which is of type string in this case, and then I will be writing in multiple lines. Okay, and then you can say rec dot val r equal to rec dot split. I am creating a variable. Okay, and this r is now of type array. Okay, And for each record, we have 4 elements. So this array will have 4 elements. Now what I have to do, I want to return for each input record, which is of type string, I want to return order object. So here I'm building the order object. Okay, before doing that, I have to create the order. So let me create that first. Without that, it will not work. Okay. And now I can actually create the order object. So here I have to say r of 0 or 2 int. This conversion is very, very important. R of 1, R of 2 dot 2 int, and then R of 3. Okay, then I'm closing the map function. So this is the functionality which we are passing as argument to the map. And that's it. It will create a RDD of type orders. So to convert into data frame, you can say val orders df equal to orders dot to df. Okay, now it is of type data frame. So RDD is one type of collection, and data frame is another type of collection which will facilitate us to perform the data frame operations or register the temp table and run as Spark SQL. Okay. So once you convert into data frames, you cannot use the typical RDD APIs on this. You have to use data frame APIs. What are those data frame APIs? You can say orders df dot and hit tab. So these are the different APIs. Similarly, if you say orders, which is of type RDD, and hit tab here, the list is different. But there are overlaps also. So data frame also have map. This one also have map. Okay. Data frame have filter. This one also have filter. But the syntax of the filter will be different. For data frames, the filter will be a bit different. For RDD, it's different. Okay, we will see those details in a moment. Okay, and on top of this, you can also see some things like select on data frames, which is not available on typical RDDs. So select, if you want to fetch few fields from the data frame, what you can do is you can say df dot select, and here you can actually say order ID and hit enter. Sorry. The syntax is not correct. Okay, yeah, syntax is correct. It has to be order underscore ID. Yeah. Now you see, I am actually fetching whatever columns I want using select clause. So this is a data frame operation, not RDD operation. So you need to have this clear distinction between data frame and RDD. The purpose of data frame is to manipulate the structured data in a bit effective manner compared to RDD code transformations and actions. Okay. And if you want to preview the data on RDD, what we used to do, we used to say take of 10 and then for each and println, etc. Here with data frames, we have API called show, which will actually get the 20 records. Okay, you can also say orders df.show, which is our original data frame. You can see even the data is a bit well formatted compared to RDDs. RDDs actually return you in the form of tuples or something. Here it is a bit well formatted, and that's the behavior of the show function. Okay, so this is a brief introduction about data frames. First, you have to load the data, and then you can actually create a RDD out of it, convert into data frame, and use a developer-friendly APIs to perform transformations on top of it. Those developer-friendly APIs are, one is data frame operations, other one is Spark SQL in native context, and other one is Spark SQL in high context. Typically, data frame operations we don't use that often because most of the developers are familiar with SQL, and it's easier to implement in SQL than DataFrame operations. Um, so typically we use Spark SQL rather than DataFrame operations. Okay. So that being said, now let us start covering a few additional APIs to filter the data, to group by, to get ranking, to sort the data. All those things we will see. Okay, and you can see those as examples here. Yeah. Anything where the data is structured, you should first prefer data frames or Spark SQL. So when you use Spark SQL in Hive context is if you are trying to get data from Hive tables, you can directly use the Hive context and directly query the tables. You don't need to create this case class and then process the data. Just hit the query against Hive, and you will get the results directly in the form of data frames. Okay, that is if the data is structured and if it is in Hive. At times you might have data which is structured, but it might not be represented in a database. You can actually define the structure on top of the data whenever you want, and you can actually register as temp table and use Spark SQL. So whenever data is structured, it is recommended to use data frames because it actually saves a lot of your development timelines, and also it takes care of many optimizations internally. Okay. For example, in the same use case, as my case class is like this. Okay. Uh, when I try to create data frame, if I do not typecast like this while creating the object, it will obviously fail. So you will come to know at the time of creating data frame itself that you are not processing the data properly. If you don't convert into orders, typically it will be RDD of string or something, and you will only realize the issues a later point in time. It can be performance issues, it can be functional related issues also. So this will actually get more sanctity to your program compared to writing core transformations and APIs. But if you keep all these things in mind, and if you understand how core transformations and APIs work, and if the minute performance difference also matters a lot, then you should go with core transformations and APIs even on the structured data. But in 99% of the cases, if your data is structured, either you have to use Spark SQL in Hive context, or convert your data into data frames and use Spark SQL. You don't use data frame operations, which I'm showing now, that often, unless you are averse towards SQL. Some of the guys in Bay Area who think themselves are esteemed developers, they don't like SQL. And for those kind of people, we have additional capabilities such as data frame operations on top of the data. But if you don't mind using SQL is the way to go. Okay, I hope I answered your question. So now to demonstrate this, I'll be using IntelliJ, because you should know how to write the programs also as an application. So for that, I'm actually using IntelliJ. So that's what I have already mentioned. If you take care of all the optimizations meticulously with the due diligence, then definitely core transformations and actions will be faster. But data frames and Spark SQL development is much faster, and also it actually gives you a lot of optimizations out of the box. You don't need to worry too much about certain things. That's what I have answered the same thing. So if you are very good at programming and if you handle all these situations meticulously, RDD is definitely faster. It's not about RDD, okay? It's about code transformations and APIs versus data frames, okay? Both RDD and data frame operations are Spark SQL. Both RDD and DF are nothing but distributed collection. DF provides you you can use data frame operations as Spark SQL on top of DF. On top of RDD, you can actually use code transformations and actions. So both are nothing but a distributed collection, and we should not compare these two. We have to compare the APIs on top of these things. And when you compare the APIs, RDD is the kernel level stuff. So if you take care of everything properly, RDD will be definitely faster. Whereas data frames make certain assumptions, which will save you a lot of time in development. At times, it can be a bit slow compared to RDD, but 99% of the cases, when you deal with structured data, or at least 90% of the cases, a bit of additional performance of using RDD might not can be negligible. That's why people tend to use data frame operations or Spark SQL rather than code transformations or APIs on top of RDD. Okay. So here, to start with the data frames, the life cycle is same. Whenever you are trying to use a new module, you need to see whether this is inbuilt or whether it is part of core API or not. So if it is not part of the core API, first thing you need to do is you have to define the dependency like this. Okay, I think I already have it. So build.sbt, I will answer that question. Shakti is asking a question. I will answer that in a moment. So first you need to make sure that your library dependencies is updated with Spark SQL. Okay. And then you can actually start developing your program. So in this case, what we'll do is we will actually use config factory or typesafe config package to load the externalized parameters. And also we need the Spark configuration, Spark context, and also additional required APIs. So one thing which you need to import is Spark SQL and Spark SQL.functions._. These two have to be imported. So there are a few questions here before. So I don't know what. Okay, this question I will answer towards the end of the session. I cannot answer at this time. I have to compare two partitions for a table and load into Oracle table. Okay. The question is also it's not clear. If you can rephrase, I know you are in the Eastern time zone. I will try to spend time immediately if your question is more appropriate. Your question is a little bit confusing. So please rephrase your question. Okay. So let me take these questions. I answered Sri's question. So Shakti is asking, what would you suggest to go with DF as part of CCA 175? It's up to you. So there is no hard and fast rule that you have to use one against other. Whatever is comfortable, go with it. Okay. So once you actually import these packages, you can create case class for orders. If you want to join more tables, you can also create case class for other stuff also like order items, etc. And the first thing you need to do is create the Spark context the way we have done earlier. Okay. So let me create the program here. New Scala class, object, total revenue, DF demo. Okay, so I hope you guys are clear on this. I'm just copy pasting these things because I have covered these things quite extensively earlier. Okay, and then def main args array of string. Okay, and then first thing what we need to do, we have to create case class. We'll create this case class outside of the object. Okay, and then we have to create configuration and Spark context object. These also I have covered already. Unless you need, I will just copy paste these things. So while creating the cons, we have to set master and app name. So here, if you want, you can use actionalized parameters to control this, like this. Okay, for that I need to first create the props equal to config factory.load. Okay, and then props dot get config. Okay, this one will be parameter. So args of 2, because this will be the third parameter which will tell which execution mode we are trying to execute the program. And then dot get. Okay, get string execution mode. Okay, and then we have created the Spark context. Once you have created this Spark context, if you want to use data frames, first thing you need to do is, you have to create the SQL context. Okay, and this SQL context takes Spark context object as the parameter. So first you need to create the configuration object using which you create the Spark context, and then using that Spark context you can create the SQL context. And here this SQL context is from this package SQL._. Okay, so we are using the native Spark SQL context. Okay, and then we can actually copy paste the this code which I have already covered from the command line. Okay, here if you see, it is showing in red. The reason why it is showing in red is we have to import something called implicits. Okay, and this implicits is part of SQL context. Okay, it is very important to import this one. Only then the 2DF function will be exposed. So first you have to create the SQL context object, and then SQL context dot implicits dot underscore will give additional nested classes of this, and we have to take care of this. So Ashish is asking you to explain props again. I have covered it earlier. You have to go back and see this topic. Okay, so I have covered quite extensively on it. So as part of develop word count application, externalize properties types of config. You have to go through this and you will get it. Okay, that's why I was saying you have to practice. If you don't practice, you will forget. Okay, and this we have used as part of the developing word count program also. And also I have covered this as part of Scala also. So this is the third time I'm using. This is not the first time. Okay, so this will actually cover create the data frame. Now you can actually say orders pf dot show. I will answer your question, Bala. Just give me a moment. And show takes the parameter. You can tell whatever number of records you want. Let's say I want to see 100. Okay. Now I can actually run this program. Here I have hard coded the input path. If I want to use, if I want to validate, I can do that, which as I have demonstrated as part of the WordCon program, and uh, uh, pass input path as parameter or argument to the program, and use the file system package to actually validate whether the input path exists or not. And if you want to write the output path to something somewhere else, you can take care of that also. So here for now, I will not be adding the validation part, but I will be changing it to the argument. Okay. So this will be the base directory for our orders. So it will be args of 0. And then the third parameter will be the execution mode, which will be dev. And if you look at the application.properties, dev.execution mode is local. So if I pass the third parameter as local, dev, it will run in the local mode. Okay. Now we are ready. The second parameter, we will not be using it here. The second parameter is for output path, but I will pass it as an argument because here I am referring to the execution mode as true. So I'll just pass the dummy path as the second parameter. But if you want to save it as an output, we have to pass appropriate value, and we can actually save using different APIs. So that being said, once the program is completed, you can click on run, and you can go to edit configurations. So the program name is not visible here. So what you have to do is you click on plus and click on application. So we can start with the name, but before getting into the name, let me pick the main class here. And our main class is total revenue DF demo. So I will give the name also the same thing. Okay, and also make sure the class path module is set to appropriate value, and then we have to pass the program arguments also. The program arguments are users, IT Varsity, research, data, retail underscore DB, the base directory where I have orders and all. And then dummy is the second parameter, and then dev, so that it runs in the local mode. Now I can right click on this and click on run this program. Okay, it is already there outside, hence it is complaining. So I will be deleting this one. So I have created a separate file for orders earlier when I was testing these things. That's why there was conflict. That's why I have deleted the case class definition from our program. Okay, here I haven't printed it. That's why it is saying like this. So what I can do is, okay, there is no for each here. Let me see what all APIs are available here. Okay, so we will not work here, I guess. I think what I have to do here is to okay, thank you, Hussein. RDD dot takeoff. Okay, I think the show also might have that. So 100 dot I think show does not have that. Select dot for each interline. That is no, it will not work. So here I have to do it like this only. Oh, actually it have displayed. It's my bad. So show works. I'm sorry. But as I have mentioned to you earlier, you should not have show as part of your program. Typically, after processing the data, we will write it to file system or a Hive table or something like that. So we need to understand those APIs and write this data back to the file system and all. You should not use show like this to display the results. Okay, but just to demonstrate, I have done this. Now let us improvise this program. Let us try to get order count by status or something. Okay, for that we need to use different APIs. To get the order count by status, first thing we just need order status and yeah, that's it. Order status and probably number one or something. Order status is enough to get the order count by status. Or let me take another example which I have already mentioned here. So here the problem statement is compute total revenue for each day for completed orders and then get results in ascending order by date. So here to compute total revenue, we need two data sets. Orders itself is not enough. We need to use order items also. So Dheeraj is asking this question. I have a Hive table with 5 columns and partitioned by one of the column, and it is in the arrow format. I have to compare 4 columns for partition P1 and partition P2. Set new column as indicator values, and this result has to load. There is no easy solution for this. You have to write an application for this. So do one thing, send me an email to training@itversity.com. I will we will discuss further on it. But there is no easy solutions for these kinds of stuff, out of the box solutions. They are not out of the box solutions. We have to develop the framework. Okay. So that being said, now let's go back to this processing here. So after creating orders data frame, let us create order items data frame. So order items have 6 fields: order item ID, order item, order ID, product ID, quantity, subtotal, and price. Okay. So here I am saying order items df equal to, this is same, underscore items dot, and then map rect, and here val a equal to rect dot split, comma, and here we have to say order items. So a of 0 dot 2 int, a of 1 dot 2 int, a of 2 dot 2 int, a of 3 dot 2 int, a of 4 dot 2 to float, a of 5 dot 2 float. Okay, now we are also creating df for order items dot 2df. I'm using here itself to convert data into the data frames. Once you have done that, so first let us take only the completed orders. So orders have 4 fields. The last one is order status. So first I want to get the completed orders only. So here I am going back to the REPL and I will try to use the first validate as part of the REPL. and then I will add it to the program, so that we don't need to run the program completely and see whether it is working or not. So here I can say order df dot filter, and I want to filter on order status. Here for equals, we have to use triple equal. Okay. And then we have to say complete. And then you can say show. I think I have to use out here. I forgot the syntax. Okay, I have to use this one. Okay, here I have to say orders df. Yeah. Also, you can actually say like this: orders df dot order status. Okay, this will not work. We have to use like this only. Okay. So orders df of order status will get us the order status for each and every record, and then you can actually say equal to complete to only get the completed orders. Once you filter the data, you want to join with order items. Okay. For that, I need to create order items df here. For that, first I need to create the case class. Okay. And then let me create this input path equal to slash users itversity research data detail underscore db. Okay, and then we can add this. Now we have order items, and also we have filtered orders. Okay, filtered orders. Let me create val order filtered equal to okay. Now I am joining orders join equal to orders filtered dot join. Let me see. Yeah. So this is how you join. You have to specify the join condition here. Unlike in RDD, what you will do, you just say orders filtered dot join and the order items. But order items has to be tuples. Here these are not tuples. These are data frames where we can access the fields. I'm sorry. Where we can access the fields using the column names as reference. So for that reason, just saying orders filtered dot join order items is not good enough. Here we have to say orders filtered, which is a data frame dot join, and we have to specify the join condition. The join condition is orders filtered of order ID equal to order items of order item order ID. Order items df. So let me check. Order filtered. Okay, I have to give the table name also as part of the join. As I haven't given the sorry. as I have given the dataset which we are trying to join, it's failed. So here I have to say order items, comma, this one. Sorry, again, it's a typo. Order items DS. Okay, now we have the joined dataset, and we can see it has a lot more fields. It has fields from both orders filtered and also order items. We can preview the data saying order join dot show. Okay, and then I want to join the data like this. Okay, and then let's say orders join dot show of 100. Okay, now we can actually right click and run this. Okay, it is showing exception here also. Input path does not exist. Okay, it's order items. It's not orders items. Probably that could be the reason why it is failing here also. Yeah, that's why it was failing. Okay, so here first we need to fix this one. That's why it is very important to preview immediately. Yeah, now you can see the data from both orders side and also order item side. And now we have to get revenue per day. So we just need to select order date and the order item subtotal, and we have to aggregate on order item subtotal by date. Okay. So what we can do here, we can do orders join dot select, and here I just need order date and order item subtotal. These are the field names, and then show. Okay, here the problem is with the syntax. I have used it quite a bit of times, but still I could not remember. Yeah, so this is how. So this will actually give us order date and order item subtotal, and then we can actually group by. Also, we can actually take care of it like this. So we can directly take the order join group by order date, and then we have to use the aggregate function on, and we have to tell which field we want to aggregate the data, and then we can take care of the rest of the stuff. Okay, so here you can say orders join dot group by, and group by field is order date. Okay, and then we have to use the aggregate function. Again, this aggregate function and all those things are part of this package, SQL context.implicit.underscore. If you don't add this thing, it will not work. So make sure you add this before you start converting into the data frame. Even 2DF is part of that only. Okay, so aggregate sum of order, item, subtotal, and dot. And if you want to get the list of supported aggregate functions, you can go to the official documentation saying Spark Programming Guide. You can see DataFrame, datasets, and SQL here. And you can actually go through the APIs here. Okay, so you have Max. They haven't documented very well. They should have given the list of functions supported, but for some reason they haven't documented it properly. Let me see. I will come back to this question in a moment. They haven't documented these things properly. They should have listed all the functions available. Probably you might have to go to the docs and check the details about what all APIs are available for us. But typical things like sum, average, min, max, all those things will work. Okay, so once you aggregate, you can actually say show to see the results. And if you see, it is actually using 200 threads to process the data, 200 tasks to process the data, which is a overkill for a very small data set. So quite often we have to override that value. Okay, so let me run this again. Here, it is showing 200 tasks to process the data. We should not use 200 tasks for this kind of stuff. For that, you need to understand something called SQL context dot set. And here you can override whatever parameter you need to control the number of shuffling partitions that should be used for your program. So the 200 is the kind of default value. Like in core transformations and actions, number of executors are 2 by default. Okay, and number of executor tasks are determined by your input size which you are trying to use. Here, number of tasks are primarily determined by a parameter called okay, YouTube screen is blank. What happened today? It's YouTube time. Okay. I think it is stopped intermittently. I don't know when it got stopped. Okay, just now. Yeah. I don't know why screen sharing is not working in YouTube Live. It was screen sharing and presenting to everyone. Is it normal? YouTube? Interesting. Let me close this and stream it again. Yeah, now it is working. Now it should be okay. Okay. So where am I at? Yeah. So here you can actually set spark.sql dot shuffle dot partitions, and you can set the value. So for this, I just want 2, so I'm setting it to 2. Set conf SQL config dot set conf. Now if you run this, it returns fast because it only created 2 tasks. Okay, and also it is saying some memory leak or something. So anyway, we will use this as part of our program also. So I'm adding this to the program. Okay. And also I'm adding this logic. Okay, now if I run, yeah, I will explain, Bala. Let it run and then I will explain. And now you can see the results. Okay, and if you go through this text, you can see it only created 2 tasks. Huh? Which one, WebEx? Okay, WebEx seems to be struck. So what I'm trying to say is now it used only 2 tasks to process the data, because we have all written this parameter called spark underscore SQL underscore shuffle dot spark dot SQL dot shuffle dot partitions. Okay, if you don't use it, it will use 200. Most of the time, it will be incorrect. Depending upon your program, you have to change this parameter. Okay, so that is this will actually in effect, if you perform any operation that requires shuffling. If you don't perform operations that require shuffling, then you don't need to worry too much about this. So that's how it works. So there are a few questions here. Okay, Bala is asking, can you please explain the join statement syntax once, and are the field names used in the join the same that we have used in the case class? That is correct. So this is how the join look like. Okay, which is highlighted in blue, and this is one data set, which is our data frame, which is orders filtered, and then dot join, and then the first parameter to the join is the df onto which we want to join this orders filtered, which is order item df, and then the join condition. As part of the join condition, we are saying orders filtered order id equal to triple equal to order item df of order id. And if you look at the case classes, order id is one field, and order items order id is one field. We are joining on those 2 fields. We can also use we can make it as complex as you want. You can actually say and or whatever you want when you actually do filters, joins, etc. Okay. So go to the documentation, define your own problem statement, and you can actually write data frame operations, programs using data frame operations. But I don't prefer using data frames that much, because it's unnecessarily complicating the things unless you are not comfortable with SQL. Okay, sure, Somalia. He's asking, can we see count of records for complete status? So here I can say orders filtered dot count 22,899 records. Okay, so that is about data frame operations. A bit important to understand how it works. But once we create the data frames, we don't need to break our head around data frame operations. They don't add much value. unless you are averse towards SQL. If you are comfortable with SQL, I would not recommend you guys to actually break your head around data frames. Spend your time on Spark SQL. When I say data frame operations. Okay. So now we will be talking about Spark SQL on the same stuff. Instead of reading data in the form of data frames and processing using data frame operations, we will read the data into data frames and we will try to use Spark SQL to process the data. So already we have this orders df. Okay, orders df dot show, which are 4 fields. Now, if I want to write a query on top of it to perform the same stuff, the way you have to do is first thing you have to say orders df dot register temp table. Okay, so this is the df name. Df name data frame have a function called register temp table, and here you will give the table name, and let us give the table name as odd and hit enter. So now your data frame is registered as a temp table by name odd. Now you can say SQL context. Okay, so what is the type of SQL context? It is of type Hive context. Instead of using Hive context, it's better to use the typical Spark SQL context, the default Spark native SQL context. That we can say SQL context equal to org.apache.spark.sql.sql context. And here we have to pass the Spark context object, and we have to use new here. Okay, now our SQL context is of type this one. Okay, so now we have changed it from Hive context to SQL context. So we have to rerun the program, otherwise it will not work. So far, whatever we have done, import SQL context dot implicit dot underscore, all those things are actually from Hive context SQL context. Now we are actually using SQL context. We have changed the data type of the SQL context. So first we have to import SQL context dot implicit dot underscore. Okay, and then we have to actually redo the stuff. So what we have to do, we have to first read the data of orders. So I'm running this. This part is same. We have converted to the data frames, and now I want to register the temp table. Okay, so this is the proper order. First, you have to create the SQL context, then import SQL context dot implicit dot underscore, then create the data frames, and then register it as odd. If you use Hive context, there can be some issues. So don't use Hive context if you want to run SQL type of queries on typical data frames. If you are reading data from Hive, it doesn't matter. You can easily use the Hive context itself. But here we are not actually processing data from Hive. We are processing the data from underlying file system by converting it into data frame. Okay, now I can say SQL context dot SQL select, let's say order status comma count of 1 order count from orders, sorry, odd. So here we have to use this one. Okay, group by order status and hit enter. You see the results will be of type data frame. Again, if you want to see the results, you can use show. And you can see the results here. Okay, so there are a few questions here. Let me have a look at that. So Ashish, I hope the question is answered by itself. Unless you register as temp table, you will not be able to run queries against it. So either you have to register as temp table and use SQL type of queries to process the data, or you can actually use data frame operations itself, the way I have shown earlier, to perform select, group by, filter, etc., which is a bit more complicated than SQL. So if you want to use SQL interface on top of this data frame, you have to register the data frame into a temp table. Only then you will be able to run the queries like this. Okay. Now I will also say I will also read order items. And then I would like to register it as OI. And now the same query to join and get the count, get the revenue by date. What you can do is you can say SQL context dot SQL, okay, and then select. We will give the aliases. So I am using O dot order date, and then OI dot sum of OI dot order item subtotal, okay, from, we can write it in multiple lines like this. Hard join OI or join OI on O dot order ID equal to OI dot order item order ID, okay, and then group by O dot order date order by O dot order date, okay, and hit enter. If you want, you can also use show. Dot show and hit enter. You can see the results. This is the order item subtotal or order revenue for each day. So this is how you can use SQL type of queries on top of data frames. The intermediate step is you have to register the individual data frames into temp tables, and you can write simple SQL queries against the data to process it. So I don't understand your question, Nasish. Is there any way we can create table using DF? Are you talking about creating table in Hive? Or Spark doesn't have any underlying file system. So within Spark, you will not be able to create any table. But if you want to save the data from DF into a Hive table, there are APIs. Okay. So what you can do is orders df dot and hit tab. And one of the API is save as table. So you can actually save as table into Hive. Okay. Also, you can use you can convert it into RDD, and you can actually save it into underlying file system also. Okay, so when a temp table is registered, is the data stored in cache memory. So when a temp table, we are only giving the name to that data frame. Data frame itself is a distributed collection like RDD. The underlying behavior of data frame and RDD are same. It will be a distributed collection on multiple nodes in the cluster. So when we register temp table, we are not doing anything with the data. We are only actually giving a name to the data frame so that we can run SQL type of queries on top of it. Registering temp table will be immediate. It will return immediately, and it will not move any data. It will not touch the data at all. When you create the data frame, RDD will be converted into data frame. At that time, probably there might be some crossing on the data. Other than that, when you register the temp table, nothing will happen. But when you run the query, yes, the data has to be processed. The same way RDDs are processed, the data frames will be processed to give the results. So RDD and data frame are nothing but distributed in-memory collections. With the data frames, we have structure, a well-defined structure on top of it, whereas RDD need not have the structure. So if you want to process unstructured data, RDD is the way to go. If you process structured data, data frame might be a better choice. So the next question from Somalia is, if I don't use DF and directly use SQL context, that will also fetch the count, right? I didn't get you. I didn't get you, Somalia. You have to be a little bit elaborate on your question. It is not clear to me. Okay. So now, depending upon your SQL skills, you can write most of the general SQL queries. So the queries can be simple joins, group by, aggregations, etc. But as of 1.6.2, Spark SQL in native does not support analytic functions or windowing functions. Okay, it is a very important statement to remember because if you want to get the uh, ranking of products, which I have demonstrated earlier, and if you try to write a SQL using DataFrame, it will not work. Okay, so there are few differences you need to remember. So Hive will be a bit behind than regular SQL because regular SQL have evolved over decades. Hive is relatively new. Spark SQL is a bit behind the Hive, and DataFrame operations are a bit behind Spark SQL. So whatever features are there in regular SQL might not be available on Hive. Whatever features that are available on Hive might not be available in Spark SQL. Whatever can be implemented using Spark SQL might not be available uh, on data frames. So you need to be a bit careful. So here there is a conversation between Shakti and Hussein. Yes. Yeah, Dheeraj have asked whether the temp tables are session based. That is correct. Temp tables are session based. Okay, Shakti is saying the result of SQL is again DF or RDD. So that you can easily practice, and if you see, take any query. If it is a data frame, if you apply the operation on top of it, it will result in data frame. If it is RDD, if you apply an operation without converting into data frame, it will result in RDD. Okay, so here I am running this SQL query again. Okay, you have to observe this output. Sorry. See here. The results of the query, nothing but data frame. So always keep an eye on this. It will answer most of your questions. Okay. So most of the APIs which we typically perform, let's say orders ds dot and hit tab. Most of these things actually result in data frames only. If it is RDD, most of the APIs result in RDD. Okay, so now we are actually getting into Hive context. We have covered data frame operations, and I have given example about Spark SQL also. For today, what I will do is I will create the program of this Spark SQL based approach, and I will run on the cluster, and I will show how it actually runs on the cluster. Tomorrow, I will talk about Hive, and I will be covering analytical and Windows functions also. In Hive context, yes, it supports, but in Spark native context, it does not support. Okay, so here I will just okay. Already I have one, so I will be using this one. Okay, you can see I am actually computing total revenue daily the same way I have demonstrated as part of the REPL. Only thing is I have filtered the data as part of the SQL query rather than filtering the data while creating the orders data frame. That's the only difference. Other than that, everything else is same. Whatever I have shown in the REPL is being done here. And also I'm saving the output into the output path. Okay. It also covers the validation using FS package and all. So we'll be running this query on the cluster. So first, what we have to do, the steps are same, deploying on the cluster. So now the development lifecycle is done. We will see the deployment lifecycle, and then we will see the execution lifecycle. The deployment lifecycle will be right-click on this copy path, go to console, and then paste that path XBT package. It will build the jar file. And then SCP. And then SSH. We might extend a bit up to 5 minutes. So we'll be done with by 10:05 because I just want to wrap it up, and then we will continue on the first topic tomorrow. Okay. So now I logged into the cluster, and I'm making sure that the jar is just copied. Yes, this jar is just copied. So now I can use Spark Submit. Okay. So as part of the Spark Submit, the class name is, I have to give the fully qualified class name. So retail.dataframes dot total revenue daily SQL. Okay. And then master yarn, because I want to run in yarn mode. Okay. Conf spark.ui.port equal to 54312. Okay, and then I want to give the jar file name, and then I have to pass the arguments. So argument first argument is input path. So here I have to give the HDFS path, which is public retail underscore DB, the base directory. And output path is user dgadiraju total revenue daily SQL. I'm just giving the program name itself. And then I want to run in the prod mode. Okay. And then hit enter. Now it is running on the cluster. We can actually go to pw01.itwork.com 54312. It is already done. That's why it is showing this error. So we can go to the resource manager web interface. So this is the program which I have ran just now. So I can click on history here. It will take us to the Spark UI, and you can see the program have ran in 2 jobs. Okay, and the first job is, see here, it actually read the data from order items, and then it performed the join. So you hear new terms here, tungsten exchange and all those things. These are optimizations for data frames which Spark developers have developed. Okay, more importantly, you should focus on this one. This will tell it is nothing but join. Okay, and once the data is joined, as part of the first job, let us see what it has done as part of the stage 3. So you can click on this. You can minimize this and go to the stage 3 and DAG visualization. As part of the stage 3, it has converted that shuffled RDD into regular RDD because we try to save it, right? So as part of the first cycle, it has executed the entire SQL query, and also it has converted into RDD. As part of the second job in this application, okay, it just picked up the data and it actually saved it into the text file. Apart from that, it haven't done anything. Actually, it performs sorting and all. So internally, the job is broken into multiple jobs. So we really need to understand what is happening in each of these pages spawned across multiple jobs. So it will take a bit of time to understand these things. So as part of the uh, first job, we read the orders, okay, and as part of the second job, we read the order items. These are simple to understand. As part of the third job, it actually performed the join and then project. So it didn't sort the data, but it actually joined the data based on this condition. And also it has projected these results, order date and order item subtotal. Once that is done, as part of the last stage for this one, it just converted the data, I don't know into what, but it says convert to save. Now it's back. Yeah, internet got disconnected. Now it's back. Please confirm whether the YouTube is working or not.
Building a website is kind of like painting a masterpiece.
Yeah, now it is back. Everything is back now. Is WebEx showing up? Yeah. So sorry for that. I think the wired connection got disconnected. I don't know why suddenly. It's not WebEx issue. It's here network got disconnected. Okay. So however, I am explaining this one. It's spawned into 5 stages, but 3 of them are skipped because these 3 stages are actually ran as part of the first job itself. Okay, and then as part of the first one, again it is doing some conversion operation, and as part of the second one, okay, now YouTube got disconnected. Just give me a moment. Okay, now it will come. Okay, now you should be able to see. Okay, so as part of the second job, it just actually sorted the data and then converted into RDD because we said .rdd, and then it saved as text file. But you don't need to convert into RDD all the time. Okay. At times there are other APIs also on DataFrame, such as save as the table, etc., which you can use to save the data into the underlying Hive tables. And also there are additional APIs such as SQL context.write. So let me show that. So Spark shell, master local. We're almost done. Just a minute. I just want to show you some of the APIs which we will be exploring tomorrow and after tomorrow quite extensively, and then we'll wrap up. And DataFrames is very important. DataFrame operations is not very important. Spark SQL it's very, very important. Spark SQL and Hive are very, very important. While it is launching, those who are on YouTube, if you like this video, please click on the like button. That means a lot for us. Anyway, now we got the session. So here I can say SQL context dot and hit a tab. Okay. You can see there is the API called read. It can be used to read the data. And on top of data frames, let me create a data frame here real quick. So this read is on top of Spark context. Sorry, SQL context. But there is one more. Okay, just give me a moment, okay? I don't want to waste your time. So I'm going back to my material, and then as part of the getting started, whatever I have, I will try to use it. So I'm creating the case class here. Okay, now the order of BF is of the data frame. Okay, now if I say order BF dot and hit a tab, on top of save as table, there is a write function also. So using write, we can actually save it into any file format. Read can be used to read from supported file formats. Write can be used to write into the supported file formats. And the supported file formats are JSON, Avro, and many other things. Okay, we will see those things tomorrow and day after tomorrow. That being said, if you have any questions, I will take few questions here before we wrap up for the day. So Dheeraj, your question is a bit complicated and also a bit out of context. So I will not be able to answer your question right now. So just send me an email, and I will definitely have a look at it, and I will try to respond. So Piyush have asked if I have a huge underlying Hive table on which we are creating a data frame. How do I optimize performance? I do not understand your question. So Hive table means it's data in HDFS. Okay. And when you run the query, if it is a 1 terabyte table, if the Hive table have 1 terabyte data, if you want to create a data frame out of it by running select star from the table, you need to have 1 terabyte memory, otherwise it will start running into out of memory issues. So your question is very highly generic in nature. So one of the approach is perform partitioning properly. Even though you have 1 terabyte worth of data, you can actually partition it in such a way that none of the partitions are more than few gigabytes, and then you can use where condition on the partition table, and it will only create the data frame out of the results. It will read the data, but it will discard without filling the memory by looking at the directories itself. So those optimizations are already taken care as part of your Spark SQL engine if you run it in Hive context. So that's the advantage of using Spark SQL. So partitioning is one strategy to optimize performance a bit. You should never load the entire table, a very big table, and create a data frame out of it. So one of the strategies to address this problem is partitioning. There could be others also, depending upon what you are trying to do. How can we do row functions? I do not understand what is row functions, Srini. If you can elaborate, I will cover. I will explain. Okay, Bala. Yeah, rank functions are analytical functions. So, Srini, those things I will cover tomorrow. Okay, Bala, definitely. I will have a look at it. Yeah, I will have a look at it. Any other question here? Did I miss any questions? Yeah, Somalia, you can unmute. Yeah, you are audible. Tell me.
So my question was like we did select platform table in CSV, right? Like using skill concept.
Okay.
So I want to get the count of records for particular status using the UMC and that using the data frame then do it, or I can do clear counts for among status and
I do not understand your question. That's what I have demonstrated, right? Let me see.
using data frame.
1 minute. Let me show you what I have done. Okay. Just give me a moment. See here. So if you see here, I just ran a SQL query on to get the auto count by status.
So ORD is data frame, right?
No, ORD is not the data frame. ORD is the temp table for data frame. So orders df is the data frame, dot register temp table, and then I have given the name ORD.
Yes, so suppose maybe there's a data frame, right? So I don't want to go into data frame. I directly want to execute this query on my SQL query. Like order.
I don't understand your question. So if you have data in HDFS, there are only 3 or 4 ways to process the data. Create a RDD out of it and use code transformations or APIs, code transformations and actions to process the data. That is one approach. The second approach is load the data, convert into data frame, which will facilitate you to either perform data frame operations or Spark SQL queries on top of it after registering a temp table. That is the second alternative way. Third alternative way is if you have data in your Hive table, you can directly run the query using SQL context.sql as long as SQL context is of type Hive SQL, Hive. So if you want to run queries using select, you have to convert into data frame and you have to register temp table, or you have to run Hive queries. Those are the two only ways using which. Yeah, go ahead.
So I was asking for Hive queries only. Select database name dot.
Yeah, that I have already covered briefly as part of the last class, and tomorrow we'll be spending enough time on that to write more complex queries.
Actually, I was setting them using this Hive queries only. I'm not getting the exact number.
Yeah. So you can actually go through my last class, and I have already covered how to run a Hive queries. And tomorrow I will be covering again about not only just connecting to Hive and getting the data from there, but also some advanced features like analytical functions and all those things. Okay. Any other question? One last question I can take. Okay, then thank you very much. And those who are on YouTube, thank you very much for joining the session. And if you like the video, please click on the like button. That means a lot for us. And if you need environment to practice, make sure you hop onto labs.itversity.com and sign up for one of the plans. And if you need help in case if you're running into any issues while learning, you can always write these issues under discuss.itversity.com. That being said, thank you. Bye.